All right, example 3 takes us to the situations that we might run into with factoring. And one type of factoring they don't hit on here, but that's, I'm sure it's going to show up in your assignment at some point. Suppose you have like x squared minus 16, that's x plus 4 and x minus 4. That's your difference of squares, so you take the square roots of the sum and square roots of the difference. That type of factoring may show up also, so remember that. This hits on all the other types of factoring that you might have to do. Right here, on this one, that's going to have a greatest common factor of x. Okay. Notice the difference between this and this. That's x squared minus 7x. They both have an x on it. X squared minus 16, that's x squared and a constant. So when you have both things having an x on it, you can take out a common factor of x. Same thing here, x cubed minus 2x squared minus 35x. We don't know how to factor anything cubed, but x is a common factor of everything. We can pull that out also. So always look for greatest common factor as an option when you're factoring. X squared plus x minus 6 is your trinomial, like the first two examples. X plus 3 is not factorable. If x is to the first power, you can't do anything to it. All right. So again, the first thing I would do on this problem is I'd rewrite this as a product. Something I personally do when I'm doing this, if I'm rewriting as a product, if there's a common factor, I take it out in this step right here. So as I'm copying it out of my book onto my paper, I'm going to be taking common factors out. So x squared plus x minus 6 doesn't have one. I might put a 1 in front of the x just to remind myself there's a 1 there. X cubed minus 2x squared minus 35x has a common factor of x. So I'm going to take a common factor of x out, leaving me with x squared minus 2x minus 35. X plus 3 that's here is going to switch to the bottom. That does not factor, but I'm going to put it in parentheses to remind myself that it's going to be treated as one object. And x squared minus 7x is going to have a common factor of x. So I'll go ahead and take that out. X minus 7 is left over. Not very difficult to take the greatest common factor out. That's the first type of factoring we learned last year in algebra. So again, that would be something you can pretty easily do. All right. And as far as the other types of factoring, I'm looking for x squares. So x to the first, x to the first, x to the first, x to the first, all those are done. We have an x squared here and an x squared here. Both of these expressions probably factor more, so we should do that. So the next step is to bring this down 1 and factor things. So x squared plus x minus 6 is x plus 3 times x minus 2. Verifying that 3 times negative 2 makes our constant negative 6. 3 plus negative 2 makes our coefficient of x positive 1. The x common factor is still here, but looking at this trinomial, negative 7 times positive 5. Negative 7 times positive 5 makes a negative 35 constant. Negative 7 plus 5 makes a negative 2 coefficient of x. Again, the purple and the green are done. I can't make x times x minus 7 any simpler, or x plus 3 any simpler. So once again, everything's factored completely. All my factors down to just x's. And what I'm looking for is common factors. So x plus 3 here matches x plus 3 there. X minus 7 here matches x minus 7 there. A single x matches a single x. And let's just say, for the sake of argument, let's say there was a 3 in front of that. 3 is being multiplied by x, which is being multiplied by x minus 7. 3 is a factor, x is a factor, x minus 7 is a factor. Individual factors can be canceled. So again, if there's even a number in front of that x, it's being multiplied, so they can be treated separately. Obviously, there's another 3 in front of this one, so I won't do that. But this x all by itself, this x all by itself cancel. And once again, we're left with a single object on top, a single object on bottom. So x minus 2 over x plus 5 is the simplest answer here. And just so you can see this, in your homework, I want to say, it might happen tonight, it might happen the next assignment. I can't remember which assignment it's in, but one of these. I think the book made a typo on one of their things because not everything cancels out, but you're left with something like this. X minus 2 times x plus 3 times x plus 4 over x plus 2 times x minus 4 times x plus 5. Something like that. My thought is that they wanted these signs to match, so all that would cancel it up to that nice little x plus 3 over x plus 5, but that didn't happen. And I considered over the years using this book to make a little modification in one of the problems so that this right sign showed up so all that cancellation happened. But then I thought it would be probably beneficial for these students to practice multiplying this stuff back out. I want to show you, not necessarily a shortcut, but just a more efficient way of doing some of this multiplication so that that's not very challenging for you, because it shouldn't be. Pick whichever ones you want to multiply together. It doesn't matter. It doesn't make it any easier if I pick these two or those two or whichever two. It doesn't matter. I personally like the last two in each case. So that and that. I can make the blue and the red as easy as possible for you. The black times the other stuff is going to be, you know, a little bit ugly, and I'd say probably a scratch sheet of paper just so you don't like try and fit all that stuff in a little box of homework paper. But here's what I would do on my paper, and I'm going to do it real quick just to show you how efficient it is, and then I'll explain to you how I got it. So I'm multiplying x plus 3 times x plus 4 in my head as quickly as you guys would multiply 2 times 5 in your head, right? Because I know where things are coming from. Based on my factoring ability, I know that I'm supposed to find two numbers that multiply to make this, that also add to make that, right? These are the two numbers. I also know the structure of a product of one of these things is always going to be x squared, something x, and something, right? The something x is always the sum of these two numbers, so 3 plus 4 make positive 7. The constant is always the product of those two numbers. 3 times 4 makes 12. Same deal here. I know this structure is going to be x squared, something x, something. The something x, if I add those, negative 4 plus 5 makes the positive 1 that's there. And negative 4 times 5 makes the negative 20 that's there. So if I'm multiplying binomials, that's all multiplying binomials is x plus something, x squared, add the numbers x, multiply the numbers to get the constant. Always works, as long as it's x plus, x minus. To do x minus 2 times the top and x plus 2 times the bottom, whatever, you got to do x times everything, negative 2 times everything. There's no shortcuts there. But there is 6 multiplications. They're not very difficult multiplications. So then I would expect you at this point, again, you have this as your answer, get to here, and then you multiply this out. X times everything first is x cubed plus 7x squared plus 12x. Negative 2 times everything is negative 2x squared minus 14x minus 24. On the bottom, x times everything is x cubed plus x squared minus 20x. Positive 2 times everything is positive 2x squared plus 2x minus 40. And then just add like terms, so x cubed, 7x squared minus 2x squared is plus 5x squared. 12x minus 14x minus 2x minus 24, no common term with that. On the bottom, x cubed all by itself. X squared plus 2x squared makes 3x squared. Negative 20x plus 2x is negative 18x, and then minus 40. So if you get to this point in one of these problems, I do want you to multiply it all back out. Again, very efficient, maybe not quite as efficient, but it gives you good practice at multiplying polynomials, so it's worth it. It happens on 1 or 2 problems the entire year, so I don't feel too bad about giving you a little bit of writer's cramp for 1 or 2 problems. If it happened all the time, I might say sometimes do it this way, other times do it the other way, but most times everything cancels except for one. That's how you handle it.